Hello, this is Miss Parks. We are in section 3.5, and we're going to be writing equations of functions, and they're going to give us the zeros. So all of this stuff is a little bit more technical. It's just saying write a polynomial f, so our function is going to be called f of x, of least degree, because there are more than one. So they're basically saying give us the basic one that has a leading coefficient of 1, because there are many equations that have zeros of 3, -2, and 4, but we're going to write the basic one that just has a leading coefficient of 1, so we don't have to worry about any of the other stuff in front of that. So what this is saying is that they're giving us the answers. So they're telling us that the answers to the function are 3, -2, and 4, which means that the function is a function that's an x to the third function. And because it has a leading coefficient of 1, I know it's going to be x to the third and then some other stuff. Okay? That's going to be the function. So let's say we were solving this problem. If we were solving this problem and at the end we got x equals 3, x equals -2, and x equals 4. Those were our zeros, like we did up here, right? Then that means that the step right before it would look like this one. Okay? So that means that the step right above this would have looked like this: x minus 3, x plus 2, x minus 4 equals 0. Well, that's exactly what's happening. We are going to be doing this problem, and then we're going to multiply this out to figure out what the equation was. So instead of working backwards and then multiplying these two out, actually, let's say these two right here, and multiplying x plus 2, x minus 4, and then putting the answers and working our way until we get to the equation, we're just going to work in this direction. Okay, so we're going to start at the top. So whatever your zeros are, your f of x equation will be x minus all of these. Okay, so we're going to have x minus, I'm going to write x minus, and x minus. So x minus 3, x minus -2, which makes it plus 2, and x minus 4. Then we're going to multiply 2 of these together. Okay, I'm going to multiply these 2 together. Okay, so if you multiply these 2 together, it's up to you how you want to do that. So if you want to use the box method, that's totally fine. I think that's what you guys are familiar with, so from previous classes. So this is going to be x squared plus 2x minus 4x minus 8. So this will be x squared minus 2x minus 8. And if you wanted to do a shortcut, you could. Only time you basically can do the shortcut because these are both just x and x, just 1x and 1x. So to get the middle term, you can just do the sum and the factor and sum backwards. So if you take these two numbers and you do, so if we have 2 and -4, right? And then we fill in our factors, we multiply them together, and then we add them up, that will give you these two numbers, okay? So if you wanted to do it that way, you could. Now to multiply this out, again, you can use a box method if you'd like. So for the box method, you do exactly the same thing as you did over here. Or you can distribute, whichever way you would like. So let me go ahead and do the box method, since you guys like to do that method. So we have x squared minus 2x minus 8. So this will give me x to the third minus 2x squared minus 8x minus 3x squared plus 6x and plus 24. So our f of x function will be x to the third minus 5x squared minus 2x plus 24. So that means that if you used these and plugged any of them in, it would give you a 0 over here. If you put a 3 in for all these x's. If you put in a negative 2 for all these x's, and if you put a 4 into all these x's, you would get that. Also, if you did synthetic, you would get a remainder of 0 if you used any of those numbers. Now, if you don't want to use the box method to multiply this out, I'm going to move this over. What you can do is you can just multiply x times all three of these. And you can multiply negative 3 times all of these. So negative 3 times x squared, negative 3 times 2x, and negative 3 times 8. And then you can add them together. And you will get this. All right, so it's up to you which method you would like to use. All right, for the next section, we are going to be using zeros that are whole numbers and radicals. So these two things are considered conjugates. One's plus and one's minus. But other than that, they're binomials, and the middle sign is different. Because when you solve a binomial, you get plus or minus when you go to solve something. All right, so we're going to write the zeros on the side. So x is equal to 3. X is equal to 2 plus the square root of 5. And because you have x is equal to 2 plus the square root of 5, when you have radical answers, they never are singular. They always have one plus and one minus because they come from the quadratic formula. So this is going to be 2 plus or minus the square root of 5. Okay, so these are the x values. Over here, we're going to write x minus those. So we have x. Let me put this in a different color so you can kind of see what's going on. So we have x minus, and x minus. And when we plug these in, we're going to have x minus 3, x minus, and then I'm going to show you something that I don't want you to write this down right now, but this should be 2 plus radical 5 in parentheses, and this should be 2 minus radical 5 in parentheses. What happens is if I distribute here, this becomes x minus 2 minus radical 5, and this becomes x minus 2 plus radical 5. So it's the same thing as if I just got rid of these parentheses because they become each other, but really they should be in parentheses. So for our purposes, as you can see, this one and this one are the same, and this one and this one are the same. So it's the same thing as if we didn't put parentheses in the first place. But just so you know, they should be there when you're subtracting a binomial. We should be able to put that in parentheses. We're going to skip that step for what we're doing because they will always cancel each other out. And so this one is really the second one because we're doing x minus this and x minus that one. And then we're doing x minus 2 and x minus negative radical 5, which makes it plus. Okay? I'm going to rewrite these just because. All right, so this first one really is the minus. But I'm just going to go x minus this and x minus that. And then for the second one, x minus the 2 and x minus the minus radical 5. If you just want to put both of them in as they are, that's totally fine. Now, when you're multiplying these, there's a shortcut to do this. Okay, so this is going to stay the same. I'm just going to leave this alone, x minus 3. And this part right here is going to be x squared minus the sum of x and plus the product. And what that means is that we're going to take these two things over here, only the radicals, and we're going to do their sum. So if I add these together, straight down, I'm going to get 2 plus 2, and I'm going to get positive radical 5 minus radical 5. Those cancel, so the sum is 4. So what I have is x squared minus the sum, so minus 4x, and then we're going to do the product. And because these are conjugates, you have 2 plus radical 5 and 2 minus radical 5. You really only have to multiply the first two and the last two together. So when we have it over here, the easiest way to do this is you're going to multiply these two together. This is multiplication. And you're going to multiply these two together. When you multiply positive radical 5 times negative radical 5, you're going to get minus 5. So that's a negative 1. So the product is minus 1. The sum is minus the sum, so it's the opposite of whatever the sum is. That's the number that you're going to have there. When you multiply these two together, instead of using the box, again, you guys can use the box method if you'd like. I'm going to go ahead and distribute this x. So I'm going to multiply x times all of these. It just makes the x power go up by 1. And then I'm going to multiply minus 3 times all of these. So minus 3 times x squared, minus 3 times minus 4x, and minus 3 times minus 1. And then I'll add these all up. And I will get x to the third minus 7x squared plus 11x plus 3. Make sure you put an f of x in front. And that's your final answer. All right, for the next problem, I would like you guys to try it and see what you get. Try the same method that I showed you in the previous problem up here. And then let's go ahead and do that. All right, so hopefully you're done now. And so the zeros are x equals 2, x equals 3 plus the square root of 7. And remember, you can't have a radical answer isolated, so you need the conjugate of that. So you change the middle sign only. And yes, I would like you guys to write these on the side. So for f of x, that equals x minus all of those. So x minus 2, x minus 3 plus radical 7. And I'm going to just leave it in the order that it's in. And x minus 3 minus radical 7. For the next part, we will be doing x minus 2. And then remember, this part is going to be x squared minus the sum of x plus the product. Now, if we didn't do this shortcut, you're going to have 3 terms. If we didn't do that shortcut, you would have to take x times all of these, then 3 times all of these, and then radical 7 times all 3 of those. So you would have 9 terms that you would add up all together to get 3 terms. I'm going to do it that way on the side. I'm going to try to do this fast motion on the video, so I'm not going to talk through it because it would sound funny, but let's see if this works out. Okay, so we're going to do it this way because it's faster than that way that I just showed, going really fast. So we're going to do sum. And again, you're only doing it of the radicals, not of the whole number. So just the two conjugates. So if I add 3 plus 3, that's 6. And if I add radical 7 minus radical 7, they're going to cancel. So the sum is always going to just be the sum of the numeric values. So this is going to be x squared minus 6x. And then the product is 3 times 3, which is 9. And radical 7 times minus radical 7, which is minus 7, which is 2. And if you go back and let me show you what I did over here, you could see that I got the same answer. It was just much messier to do it this way. Okay, here we go. So let's finish this up. In this part, I don't use the box method because I think it just takes a little bit more room. It's a little messier, but you're welcome to use the box method to finish this up. So x times all of these just makes those all go up by 1 power. And then I will do negative 2 times all of these. So negative 2x squared, negative 2 times 6x, and negative 2 times 2. And when I multiply all of those together, add all of those together, we get x to the third minus 8x squared plus 14x minus 4. Put an f of x in front of it, and then that's the answer to that one. Please try the last one just for a little bit more practice. I think it'll be good. Okay, now that you're done with that, I'm going to do that. I'm going to do it fairly quickly because at this point I think you should have been able to, or you'll be able to check your answers a little bit faster. So this is going to be 1 plus the square root of 5. All right, so f of x is equal to x minus all of those. So x minus 4, x minus 1 minus radical 5, x minus 1 plus radical 5. The x minus 4 is going to stay the same. This will be x squared. And then here, I would like you guys to also do the sum. Sum is adding the whole numbers together. The radicals cancel, so minus 2x. And then product. The product, I multiply 1 times 1. Sometimes people multiply 1 times 1, and they put 2. And then I multiply negative radical 5 times positive radical 5. So that's minus 5, so that's minus 4. Then I will multiply x times all 3 of these, x to the third, 2x squared minus 4x. And then I will multiply negative 4 times all 3 of these. So negative 4 times x squared, negative 4 times negative 2x, and negative 4 times negative 4. Adding all of these up together, hopefully this is what you got for your answer. X to the third minus 6x squared plus 4x plus 16. Don't forget the f of x equals in front of that. And that is your final answer for this. And hopefully you understood that. We're also going to be doing imaginary numbers, which is in the next section. So I'm going to switch over there right now. Okay, so if you're trying to figure out where we are in the notes, I'm in section 3.6 now. Okay, and I'm in example 3. Okay, so section 3.6. And example 3. So we just finished writing polynomial equations, functions, when they gave us radical zeros. And now we're going to be doing imaginary. So we haven't really talked about imaginary numbers a lot. Hopefully you talked about them when you were in integrated math 2. However, we are going to be writing equations that have imaginary numbers. The only thing that you really need to know for this section is that imaginary numbers are also in conjugates. So if I had 3 plus 2i, then I would have to use 3 minus 2i as an answer. Imaginary numbers come from radicals that have negatives inside of them. So I is really equal to the square root of negative 1. However, for our intent, for what we're doing, every time you have an I squared, it equals a negative 1. So this is equal to 5 times negative 1, which is negative 5. So if you have an I squared next to a number, you basically can remove the I squared and change the sign of the number. So if I had negative 5i squared, it would equal positive 5. And the reason it would equal positive 5 is because it'd be negative 5 times negative 1. So anytime you have an I squared, remove the I squared and change the sign of whatever's next to it because it just means times negative 1. Okay? So we're going to do these problems the same way as we did the last ones. And here we go. So we have x is equal to 3, x is equal to 3 plus I, and x is equal to 3 minus I. Okay, so these are my zeros. Remember that for radicals and imaginaries, they need to have two answers, a plus minus, because it comes from the quadratic formula. Okay, so here we go. F of x is equal to x minus each of those. So x minus 3 plus I, x minus 3 minus I. And again, it's minus this quantity. So it would be x minus 3 plus I, which makes it minus 3 minus I. And x minus this quantity, which would make it minus 3 plus I. We could just write them as they are because they always kind of become each other. All right, same as last time. We will have the first one remain the same, and this will be x squared minus the sum of x plus the product. And again, we're talking only about the conjugates, not about the original answer here. The 3 has no part in this. So we're going to be doing sum and product, just like we did for the radicals. So the sum, if you add these together, is 6. The imaginary numbers will cancel out. So we have x squared minus 6x. The product, you multiply 3 times 3, so that's 9. And positive I times negative I gives you negative I squared. So that's 9 plus 1. So that'll be 10. And why is it 9 plus 1? It's because it's 9. And remember, I squared is equal to negative 1. So anytime you have an I squared, it equals negative 1. So the minus negative 1. So it's 9 plus 1. So the I squared is basically always going to make this part become positive instead of negative. So if you remember radicals, they were always minus. And for imaginaries, the second part will always be plus. And then you finish this the same way we did in the last section, which means you multiply x times all these. And again, you can use the box method if you prefer. And then I'm going to multiply negative 3 times all of these. So that would become negative 3x squared, negative 3 times the middle term, and negative 3 times the last term. And then if we add all these together, x to the third minus 9x squared plus 28x minus 30. And then we make sure we put this f of x at the beginning for the function. All right. All right, for this one, I would like you guys to go ahead and try this and then check your answers. So pause the video and then come back and try this. All right, here we go. X minus all of those. So this is x minus 5. This is x squared. And then we're going to do sum and product over here. The sum is 4. The imaginaries cancel out, so minus 4x. The product, you multiply 2 times 2 together. You multiply these, remember, it's multiplication. So we multiply both of those. That becomes minus 25i squared, which is 4 plus 25. So that's plus 29. Remember, the I squared is negative 25 times negative 1, which makes it plus. So an I squared next to a number changes its sign. All right, so now we're just going to finish this up. X times all of this, x to the third minus 4x squared plus 29x. And negative 5 times all three of these. So negative 5 times the first one, just keep track. Negative 5 times the second one, plus 20x, and negative 5 times the last one, which is negative 145. Adding all these together, x to the third minus 9x squared plus 49x minus 145, and then we have an f of x in front. All right, for the last problem, you have to be a little bit careful. The first thing you need to realize is where are the commas, because a lot of times people will kind of mess this up and see how many zeros there are. So we have x is equal to 3. Then we have x is equal to 4i. Anything that's imaginary or radical has to have a conjugate. So the conjugate of 4i is minus 4i. So you need to use that. Then we have x is equal to 3 minus radical 7. So you must also write x is equal to 3 plus the square root of 7. So what we have is we have 5 zeros, which means that we're going to have an x to the 5th equation, which means this is going to take quite a bit of work. Okay, so let's just stay organized and it should be fine. So x minus all of those, x minus 3, x minus 4i, x minus negative 4i, x minus 3 minus radical 7, and x minus 3 plus radical 7. And again, we would just change the sign of both of those. All right, so for this, we're going to leave this alone, x minus 3. Let me write this underneath so you can kind of see what's going on. If you want, you could do sum and product here. And actually, let's just go ahead and do that if you want, just so that you don't get confused. So if we're doing these two, the sum is 0. And the product is negative 4i times positive 4i, which is negative 16i squared, which is positive 16. So this is x squared plus 16. You can also just multiply these because they're conjugates. You can multiply them like that, and you would get x squared plus 16, which is the same thing. Now, for this part here, we're going to do the same thing. The sum and product of these two. Let me go back to the last one and make sure you know that you're just doing the sum and product of these, not the x values. All right, so the sum of these two is 6, and the product is 3 times 3, which is 9, and negative radical 7, positive radical 7 is minus 7, so that's 2. So this would become x squared minus 6x plus 2. So now we have all of this. If we're going to multiply all of this together, there's a couple of different ways of doing that. We'll figure that out. So if I want, I can multiply these two together first and then multiply it by this, which I think I'm going to go ahead and do that. So I'm going to leave this alone, this x minus 3. So I'm going to bring that down here. And then in this case, I'm going to multiply x squared times all of these. So that gives me x to the 4th, x squared times minus 6x, 6x to the 3rd, plus 2x squared. And then I'm going to multiply 16 times all of these. When I do that, I need to make sure I line these up correctly. So 16 times x squared is positive 16x squared. 16 times negative 6 is minus 96x. And then 16 times 2 is plus 32. So when I add all these together, I'm going to put this right in front of this, but x to the 4th, then minus 6x to the 3rd, and then if I add these two together, actually let me put it where it goes so that it makes more sense. I'll move this over. So this will become x to the 4th minus 6x to the 3rd plus 18x squared minus 96x plus 32. And then I still have this x minus 3 that I have to multiply times this. I want to move that there. All right, so when I multiplied these two together, this was the result. If you rather use the box method to do that, that's totally fine. Now I'm going to multiply these two together. So in order to multiply these two together, multiply x times all of those. That becomes just one higher on all of them. x4 18x to the third, 96x squared, plus 32x. And then I'm going to multiply minus 3 times all of these. Okay, so if I multiply minus 3 times all of those, minus 3 times x to the fourth, minus 3 times 6x to the third, minus 6x to the third, that's positive 18. Negative 3 times 18x squared, that's minus 54x squared. Negative 3 times negative 96x. What's that? 270 and 18, so 288. And negative 3 times 32, which is negative 96. And now if I add all of those together, that will be my final answer, which is x to the fifth minus 9x to the fourth plus 36x to the third minus 150x squared plus 320x minus 96. And you will not have very many questions like this. But if you could do this one, you can do any of them. Just remember that imaginaries and radicals always have a conjugate. So they're never, you're never going to have one single imaginary zero or one single radical zero. And that covers it for writing equations when the zeros are given to you.